remembrance-kjv.com, video number 26. You are welcome. In this video, we are going to use the Chinese lattice method to try and manage compound multiplication involving multi-digit multipliers and multi-digit multiplicants. So, we have 534 multiplied by 8, 24, plus 7, 91, multiplied by 5, 80, plus 2, 16, multiplied by 6, 37. The pre-multiplying numbers are written column-wise in corresponding order of closeness from the grid box to their post-multiplying numbers. So, we have 2, 16 closest, since 6, 37 is also closest. 7, 19 in the middle column, since 5, 80 is also in the middle row. And 5, 32 in the outer column, since 8, 24 is on the outer row. Let us begin the computations. It's 5 times 8, 40, plus 35, 75, plus 12, 87. Next, 3 times 8, 24, plus 45, 69, plus 6, 75. Next, 2 times 8, 16, plus 5, 21, plus 36, 6, 57. Next, 5 times 2, 10, plus 56, 66, plus 6, 72. Next, 3 times 2, 6, plus 72, 78, plus 3, 81. Next, 2 times 2, 4, plus 8, 12, plus 18, 30. Next, 5 times 4, 20, plus 0, 20, plus 14, 34. Next, 3 times 4, 12, plus 0, 12, plus 7, 19. Last, 2 times 4, 8, plus 0, 8, plus 42, 50. And we are done with the grid of sums of partial products at each positional value. We now sum up numbers of the same positional value. First diagonal, 50. Second, 49. Third, 172. Fourth, 147. Last, 87. Now, we convert this result, which is in partial sums, to single-digit positional values. It's 87, 870, 1017, 10170, 10342, 3420, 3469, 34690, 740. This is our final answer. 740. Notice that with experience in mental arithmetics, this bottom stage can be omitted. With further maturity, the numbers of the grid box can also be omitted in the like manner we demonstrated in the previous video, video number 25. Try it yourself and practice it with numbers of your own choice. Now, let us analyze this method of calculation. It's 5 times 8, 40, plus 7 times 5, which is 35, plus 2 times 6, which is 12. 40 plus 35 plus 12 gives 87. Let us add clarity. Let us split the grid to the right like this. Move the column numbers a little bit to the left like this. Bring down the row numbers like this. Oh, it looks like these are matrices. Let us try and see. Let us arrange 40, 35, and 12 in a column like this. Let us find out. 40 is 5 times 8. 35 is 7 times 5. And 12 is 2 times 6. Yes. That's row column multiplication. The same algorithm employed in computing matrices. So, these are matrices. The only difference is that with matrices, the grids are removed. If we use the approach used in matrices, we will come up with the same numbers for the resultant grid. But what we are again observing is that elements of the pre-multiplying matrix are written column-wise, while those of the post-multiplying matrix are written row-wise. This observation is not written in any textbook on matrices. This is why people cannot explain as to why when matrices are interchanged in multiplication, the first product is different from the second product. What can be deduced from this calculation is that when matrices are interchanged in multiplication, then each of them has to be transposed. The resultant matrix will also be a transpose of the first resultant matrix. However, the final answer of the multiplication of the numbers being multiplied remains the same. What we are saying is that if the matrices above are transposed and finalized, the final answer is still 1034, 740. So, matrices that are taught using School's method are left without being finalized. The resultant matrix is not reduced to the final answer. Do you still remember what Thomas Fuller said concerning learned people? He said, most learned people be themselves great fools. And is that a lie? How many textbooks do we have on matrices and transformation? Is it deserving to learn these topics at undergrad level? Topics that can be taught to 10-year-olds. We are in a situation that should be pitied sorrowfully when after college we claim that we are learned people. God should help us. Meet you in video number 27, where we will take a look at other methods of managing multiplication.